Welcome to another episode of Beyond Today. Since the dawn of the time, we human beings are finding a way to make our lives comfortable with research, science and technology, findings, new innovations, discovery, and inventions. Due to this, directly or indirectly, we have affected our Mother Earth. Hence, a new wave of mindsets have brought us into this era where renewable energy with natural resources could help not only us, but bring change in the climate. New evolutions are taking place where industries are focusing in developing new tech in electric and moving from combustion engines to battery-based technologies to power not only home appliances but and electric vehicles. Earliest batteries. It is known that before inventing electricity, the batteries were invented, and that is the source of our change in the present times. Batteries have come a long way. Before Benjamin Franklin discovered electricity in 1740s, the concept of batteries may have already been in existence since as early as 2000 years ago. In 1983, a group of archaeologists have discovered a collection of terracotta jars in Kujutu Rabu, a village near Baghdad. Jars contain sheets of copper rolled up in an iron rod. Wilhelm Kolong, one of the German archaeologists, discussed the possibility of these coppers and iron combination as a form of galvanic cells used as a battery. When mixed up in the acidic liquid, copper and iron can produce a chemical reaction that results in electricity. It is thought that this earliest form of battery may have been used as electroplate gold into an artifacts of an Parthian civilization. The Parthian civilization dynasty existed between 250 BCE to 250 CE. The journey which led to a creation of a battery as we know it today involved one invention after another. Take a look at the historical timeline of the battery and how ideas for this development came to be. The battery evolution started from 1786, frog legs and electricity, came up to 1800, the birth of a voltaic pile, 1820, the Daniel cell battery, 1838, the porous spot cell, 1899, the Nickel-Cadmium battery, 1903, the Edison battery, 1955, the arrival of alkaline batteries, 1912, lithium and lithium-ion batteries. In 1912, lithium and lithium-ion batteries where Gilbert Newton Lewis started with the experimentation on a lithium battery, but it was not until the later part of the century that the first lithium batteries became commercially available. Three important developments were vital to the creation of these batteries. The discovery of LiCoO2 cathode by John in 1980, the discovery of a graphite anode by Richard Yamazaki in 1982, and in the rechargeable lithium battery prototype produced by Asahi Chemical Japan. Later, Sony commercialized the lithium battery ion bit in 1991. Ion batteries, which got popularized in 1991, became commercialized by many companies. Analysts predict that by 2030, electric vehicles will outsell the conventional ones. Soon it might become cheaper or comparable to buy and operate electric cars as opposed to an internal combustion engine vehicles. Having an EV car means spending less money on servicing and maintaining it. Moreover, they are better for the environment as they do have zero exhaust pollution and can renewable energy to charge. Game-changing solid batteries, lighter, much more powerful than current lithium-ion batteries. So what is solid-state batteries? Much the same way as a normal battery works, with the flow of the ion trigger a chemical reaction between the battery materials called redox, where when discharging power oxidation occurs at the anode to create compounds with the free electrons, which delivers electric energy, and reduction at the cathode, which sees compound gain electrons and thus store power. When the battery is charged, the process is reversed, much like lithium-ion batteries. When delivering power in a solid-state battery, aka discharging positively charged ions, travel through the electrolyte from the negative electrodes anode to the positive one cathode. This leads to buildup of positive charge in the cathode, which attracts electrons from the anode. But as the electrons can't travel through the electrolytes, they have to travel across the circuit and thus deliver power to electric motor. During the charging, the opposite happens with the ion flowing to the anode, building up a charge that sees electrons pull to it across the circuit from the cathode. When no more ions will flow to the negative electrodes, the battery is fully charged. the drawbacks to the solid-state battery, you might wonder why solid-state batteries aren't being used in EVs. They seem to be a solution to the problem is lithium-ion battery, but the challenge with the solid-state battery is that they are very difficult to manufacture at the scale. Not only are they currently too expensive to be pushed out into the commercial use, there is still a lot of work to be done to make them ready for the mass market use at the moment. There are still need to find the right atomic and chemical composition for this solid electrolyte that has the right ionic conductivity to deliver enough power for an EV motors. Getting the solid electrolyte right in particular important as it is precursor to allowing the use of lithium anodes, which can produce more lithium ions and thereby more energy a solid state electrode. A solid-state electrode is thought to be a solution to this problem of damaging needle-like structure called dentures, forming an anode as it charged. Compared to conventional lithium-ion, solid-state lithium metal batteries are much lighter, more powerful, take up less space, charge faster, last longer, and present much lower less flammability as in a solid-state batteries. There is no liquid electrolytes, which makes it safer and should improve its energy density to allow quicker charger and increase range. There is even a potential for eliminating expensive thermal management systems seen today. Next generation batteries such as solid-state and metal air batteries are safer and demonstrate higher performance than lithium-ion batteries. Companies such as Toyota, Samsung are currently working on the research and development, including the production technology of solid-state batteries, and have achieved ultra-small BEV driving. Toyota and Volkswagen are forced heavily on a solid-state engineering. Toyota has announced plans to have a solid-state battery in a running prototype by 2021 and in production vehicle by 2025. Volkswagen has a partnership with Quantum Space in California, which has announced test results for a solid-state cell. Samsung also has developed solid-state battery using silver carbon instead of lithium, while Ford and BMW are working with Colorado-based solid power. Mercedes-Benz is working with Hydro-Quebec in Canada. How solid-state batteries can transform electric cars. We haven't perfected lithium-ion batteries for electric cars, but the race is already on to replace them. Solid-state batteries are getting the most buzz as they are here apparent. Their proponents promise they'll deliver longer range, faster charging, and more affordable electric cars compared to today's top EVs like Tesla Model 3 and Chevy Bolt. A solid-state batteries is exactly that, a tightly compressed arrangement of hard materials rather than a slightly mushy stew that makes up typical lithium-ion batteries. That solid-state composition and construction yield an electrochemical device that promises a lot of improvement. Toyota and Bloomberg announced greater energy density. This could mean a EV with 2 or more times the current range, or possibly an EV with the same range but a much smaller, lighter and less expensive battery that charges faster. Faster charging, estimates up to 80% charge in 15 minutes, get banded over a lot of solid state performance that would be a par or bit faster that is today's best ionic or ion-based applications. Stability. Solid-state design promises less likelihood of thermal runaway, which can cause a fire. Lithium-ion batteries have developed a nasty reputation for this. On the whole, with all the innovations in the arena of the batteries and innovations, we are striving not only to make the life emission-free and to better the climate. These innovations and discoveries will come to reality when these changes are effective and tested on the real life, for which we all will come to know. Beyond Today. This was all happening this week in the world of stocks and market. If you haven't subscribed yet, then you can like and subscribe by hitting the subscribe button. Beyond Today's Stocks will continue to bring the latest update from the world of stocks. Enjoy the video and have a good one.